All right, so this is learning check 2. Again, do this problem on your own and then hit play and correct your work. And if you really get off track, watch the whole thing and then start over again. You can watch it as many times as you want. Same with the videos in the course video library. You can go back and redo the worksheets and then watch the videos to see if you really have it down. Okay. What do I need to do? Okay, so let's read it. A hot air balloon flying horizontally at a velocity of 50 meters per second and an altitude of 475 meters when one of the sandbags falls off. How long in seconds does it take the sandbag to reach the ground? And what horizontal distance in meters will the bag travel before it strikes the ground? So go ahead and hit pause. And welcome back. So if you were not sure where to get started, remember we do that little guess thing. Okay, we're going to circle what we know. Okay, and it even tells you here that's a velocity. Okay. This is an altitude, so we know that's a distance. And what type of velocity is this? This is velocity at the start, so an I, in the horizontal direction. So you could label it as X, or velocity initial in the horizontal. Most of the time you're going to see me label it like that. Okay. And what do we need to find? We underline our unknown. How long? So that's our time there. And our second question, we're going to need to know what the horizontal distance is in meters. Will it travel? So this distance here is your vertical distance or your distance in the Y. And down here is your distance in the X. Sometimes people call the 475 a height. Sometimes people call the distance in the X a range. So lots of different things there. So equation. Sometimes you sit here and go, I have no idea. So put this S first. Draw in that sketch to help you out, because that's going to actually help you solve this problem. We have a balloon and it is going to the right at 20 or 22. Where am I getting 22 from? 50 meters per second. And then we're going to lose a sandbag, and that sandbag is 475 meters above the earth. And we assume it's the earth. It's going to fall in this type of motion right there. What is pulling it down? Gravity is pulling it down. So our acceleration is due to gravity. Now we got to think a little bit. Our range here is what we're going to be finding for part B. When I'm talking about this sandbag, okay, the hot air balloon is going horizontally. But what am I only concerned with? Vertically. Vertically, what is the balloon doing? The velocity in the Y is equal to 0. It's not going up and down. So this guy might as well have been dropped from rest. So its velocity initial equals 0. And that's probably one of the harder things on identifying there, is remember we're separating out X and Y. It's being dropped. So it doesn't matter that the balloon is moving horizontally, it is just being dropped. There's nothing pushing to add to it. There's no initial velocity throwing it down. So the only thing that's affecting it is going to be that acceleration due to gravity. Okay, so now maybe it'll be a little bit easier to find our equations, because we notice that 50 meters per second, we don't actually need to know it for this part. Okay, so what do we know? Okay, do we know velocity final? We don't know velocity final. Velocity initial, yep, we know that's 0. So I'm going to circle on my velocity initials. And what else do we have? Acceleration is gravity. So I'm going to circle all my A's. Okay. And we know that our height is 475. So that's our distances, because we're all concerned just within the Y direction. So we're not going to worry about this range or X value now. And now let's go back. So to find the time, those are my underlines. I could use equation 1 or 2, but equation 1, I would need velocity final. I don't have that, so I'm going to use equation 2. Distance is equal to VIT plus 1/2 AT squared. Okay, now if you're comfortable, try to substitute it in, hit pause again, and then hit play and see if you can follow out for that rest of the way. Now I'm going to add some things here just so that you can see it, but I know sometimes that gets confusing. The distance in the y is equal to the velocity initial in the y times the time plus 1/2 acceleration in the y times t squared, because that's actually what we're doing here, because we're only talking about the y direction. And now let's substitute. Distance in the y will be 475. Velocity initial in the y is 0. So I don't have to worry about that time component because anything times 0 is 0. Acceleration is due to gravity, 9.80. And then that time I'm going to leave as a t because that's my variable. 475 equals 1/2 times 9.8 times t squared. Okay. Combine like terms, 475 equals 4.9 times t squared. That 4.9 is connected to t squared multiplication. So I'm going to divide. What I do to one side, I got to do to the other side. So that's going to give me t squared is equal to, let's see, it cancels out on the left or on the right, 475 divided by 4.9. Is 96.94 seconds. Okay, so that is what you would want right there for your time squared. What do I have to do to get time? Well, to get time by itself, I have to take the square root. And what I do to one side, I do to the other side. And that gives me a time of 9.85 seconds. Always in physics for here, use 2 decimal places. So there is my answer for part A. Now go ahead and if you're like, okay, yeah, I got that. If you haven't done B yet, hit pause, try that one out. Try to see if you can get which equation that you would use for this guy. So what horizontal distance in meters will the bag travel before it strikes the ground? So, what is actually happening? Do I need a picture? Do I need a picture? I think I do need a picture because this is talking about horizontal distance. Okay, this velocity initial, this acceleration due to gravity, this height, that's all in the y. What's happening in the x? 15 meters per second and that range. That's it. So this is 50 meters per second. And I need a distance. But I do not have any of those other equations because I don't have an acceleration in the x. It's constant, okay? It's as a velocity of 50 meters per second. So that's not going to help. I don't have an acceleration. So that's not going to help. Can I do my velocity initial times time? Maybe I can use that part of the equation. Let's go look at the top. Again, no acceleration. Velocity final equals velocity initial. Well, that's true, but that's not helping us here, right? Because we already do know it's constant, so the velocity wouldn't be changing. So I can actually use this one. Distance equals my velocity initial times time. I'm doing the x direction here. Distance in the x, velocity initial in the x. Okay. Do I know my distance in the x? No, I don't, because the 475 is the distance in the y. Do I know the velocity in the x? Yes, that's at 50 meters per second. And how much time did it take to fall? It took 9.85 seconds. Time does not have an x or y component, so I can use it either way. And did you notice this equation is basically average velocity is equal to distance over time. That's how they all work and are connected. So 50 times 9.85 gives me 492.5 meters. And that is the x distance that has traveled. Does that make sense? Let's talk about that. If I move 500 approximately meters along on the balloon, okay, that's going to take how long? It's going to take 9.85 seconds. So when I'm thinking about the bag traveling, it started off at 50 as well. So it's also getting that same benefit of that distance because we're not dealing with air resistance. So there you go. Wait till the end to make sure you submit your scores if it's a quiz, and have a great day.